we're told the terms 1 through 4 of a sequence are shown below. Write the recursive formula for the sequence in two forms, including the initial term. So either we can use the form with the function notation, and the initial term would be f of 0, or we could use what I would view as like the term subscript notation, a sub 0. So pause this video, have a go at this before we do it together. So let's just start looking at what's going on here. So this is the first term, this is the second term, third term, and then fourth term here. It's a little confusing with that comma, but this is 1,377. And before this, we're going to have a 0th term that we're going to want to figure out. But when we go from 51 to 153, well, first we have to figure out, is this an arithmetic sequence? Are we adding or subtracting the same amount? Or is that the difference changing, which means that we're probably multiplying, not always the case, but maybe multiplying by the same amount? Well, the difference seems to be expanding. And when you look at it, it looks like to go from 51 to 153, you multiply by 3. You multiply by 3 again, and yes, you get to 459. And you multiply by 3 again. I'm doing this roughly in my, yeah, that looks about right. So it looks like what is happening here is every term, so f sub n, the nth term, is equal to the term right before that times 3. So we could write 3 times f of n minus 1. Or if we wanted to use the subscript notation here, I could write a sub n, the nth term, is equal to 3 times the term before it, the n minus first term. Now, what is f of 0 or a sub 0? Well, to go one term back, instead of multiplying by 3, we just divide by 3. Or another way of thinking about it is, what do we have to multiply by 3 to get to 51? Well, 51 divided by 3 is 17. So we could write f of 0 is equal to 17. That's that initial condition, so to speak, or where we're starting from, or the initial term. Or we could write a of 0, a sub 0, is equal to 17. And we're done.